Hello ladies and gentlemen, this is Mr. Cunningham, and we're going to be going over lesson 13.4 today, which is over, you guessed it, stoichiometry, and this will be stoichiometry with solutions. So what I want you to do is go ahead, take a few minutes, and fill out those bell work questions, then we'll talk about our objectives. Alright, so now you've been able to go through those bell work questions. Let's go ahead and talk about what you're going to learn in the video today. First of all, sub-objective 1. When given density or molarity, be able to convert to moles. That's the first thing you should be able to do. Given those things, be able to convert to moles. Sub-objective 2, be able to balance a chemical equation. Again, you can't do stoichiometry unless you know how to balance a chemical equation. And our goal, use a given concentration and volume to solve for an unknown variable using stoichiometry. So here's the question we are trying to answer today. It says, so here's our chemical equation. It says when you use 25 milliliters of 4.0 molar HCl to produce H2 gas, how many grams of zinc does it react with? Okay, so that's what we're trying to do. Let's go through some of the stuff that we're going to have to know before we can do this type of problem. So, first of all, let's review some of the ways that we know how to get to moles. Well, here are the ways that you should know. Well, we can do grams divided by the molar mass. So if I know grams of something and I divide by the molar mass of that substance, I get moles. Then, if I take my number of particles and divide by Avogadro's number, which is 6.02 times 10 to the 23rd, that can get me to moles. I can use, like we did in last unit, I can use PV equals nRT. So if I know pressure, volume, and temperature, R is a constant that we always have, I can solve for N, which gets me to moles. The last thing, I guess one of the first ways we learned was how if we're given liters of a substance and we're at STP, then we can just take liters divided by 22.4 and that will give us moles at STP. Okay? We have two new ways that you've learned in this unit to convert to moles of a substance. Okay? And again, the reason why we have to convert to moles is in stoichiometry. In order to do stoichiometry, we have to get to moles of one substance so we can convert to moles of another substance. So, we did this concept map in one of our earlier lessons. Again, we're going to kind of be referencing that, and I'm also going to give you a new concept map today just for stoichiometry. So, what are the ways that we can now convert to moles using that concept map that I just showed you? Well, here's the first way. The first way is if I take the molarity of my substance and multiply by liters. Okay, so if I go back, if I know my molarity of my substance and I want to get to moles, well, if I take molarity times liters of solution, I get moles. Okay, that's one way we've learned. The next way we've learned is to take the density of a compound times the volume and then divide by the molar mass of that compound. Okay, and again, here's how we do that on this mole map. If I know my density, okay, and I multiply by my volume, that gives me grams of my compound. And if I know how many grams I have, and I know what the compound is, then I can divide by the molar mass, and that will give me moles. That's our second new way that we've learned in this unit. Okay, so we've got these two ways. All right, what we're going to do in this next part is we're going to go over how we do those, kind of rehash how we do those conversions. So, the first way, again, we said is by using our molarity equation. Okay, so capital M here means molarity. Molarity is equal to moles divided by liters. So let's say I have a molarity of something and it's 0.2 molar sodium hydroxide. Then I can find moles of the substance if I know the volume, and let's say it's 100 milliliters. So molarity times liters gets us moles. All that I did is I rearranged this equation. What I would do is I would multiply by liters on both sides, and that would get rid of liters on this side, but put liters on this side. So now I have molarity times liters gives me moles. That's the way I convert. So if I was going to do that with this problem, what I would do is I would take my 0.2 molarity, which again, molarity means moles per liter. Okay? So my liters are actually going to cancel out on the bottom. So I'd have 0.2 moles per liter times 0.1 liters, and that's going to give me how many moles I have. Okay, that's the first way to convert. Here's our next way. So what if I'm given density? How can I convert from density all the way to moles? Well, density is equal to mass divided by volume. So if you know the density of a pure substance, let's say that my density is 0.63 grams per milliliter, and if you know the volume, let's say I have 75 milliliters of it, then you can find the mass of the substance. Then once you know the mass, you can convert grams to moles if you know what the substance is by using its molar mass. So let's say I have a density of a substance, it's 0.63. Let's say I have 75 milliliters of it, and let's say that I know my substance is C5H12. So here's what I'm going to do. I would take density times my volume, and that will give me my mass. Then I'm going to take the mass that I just got, divide by the molar mass, and that will get me to moles. So here's what that would look like using dimensional analysis. I have a density of 0.63 grams per milliliter means I have 0.63 grams for every 1 milliliter. So I'm going to take, that's my density, and I'm going to multiply that times my volume. Well, my volume was 75 milliliters. And again, the reason I'm going to leave this in milliliters in our previous slide, I changed my volume to liters, and that's because in the molarity equation is moles per liter. Density can have varying units of volume. So because this was milliliters here in my density, I needed to use milliliters for my volume. So I take, I would multiply by 75 milliliters. That's going to give me my mass, which means if I had a 75 milliliter sample of a substance that had this density, it would weigh 47.25 grams. Now that I've got my mass, I can now take my mass and divide by my molar mass. Well, since I know what the substance is, since I know it's C5H12, I can find its molar mass. So I'm going to take 47.25 grams, the mass of that compound that I have, and I'm going to, again, set up my dimensional analysis. I'm going to divide by 72.17, and that's because I need to cancel out my grams so that I can get moles. Since grams appear here and here, those grams will cancel out, and the only unit that will be left, which means I have 0.65 moles of this compound. Okay, so those are the ways that we've learned how to convert from density to moles and from molarity to moles. Okay, so this is now your new mole map. I want you to take a minute and get this copied down. It's on the back of your notes page. I've gone ahead and put all of the arrows and all the circles on there. All you guys need to do is fill in what goes inside the circles and what goes along your lines. In other words, what do you need to do in order to do those conversions? Take a minute and do that. So now that you've had some time to fill in this mole map, now we're actually ready to look at our problem. So here we go. So our problem says when you use 25 milliliters of 4.0 molar HCl, or hydrochloric acid, to produce H2 gas, how many grams of zinc does it react with? So again, because we're doing stoichiometry, the first thing we need to do is we need to make sure our equation is balanced. And again, how we know this is stoichiometry is because it gives us information about one substance and asks us for information about another substance. So I'm going to balance the equation, assign my known value, my substance A, and my unknown value, my substance B. Okay, so I'm going to go ahead when I balance my equation, again, because I have 2 chlorines on this side and 2 hydrogens on this side, but I only had one of each. I only had 1 hydrogen and 1 chlorine on this side. That means I need a 2 right here. So my equation is now balanced. Now I need to assign my known and my unknown value. So this is where we would say, okay, what do we know information about? Well, the only substance that it gives us any information about is HCl. It gives us its molarity and its volume in milliliters. So HCl is going to be my substance A. Then it asks me to find how many grams of zinc does it react with. That means zinc will be my substance B. So I've got my A and my B labeled. Now, here is my roadmap. In other words, if you look at your roadmap that you just wrote down on your notes page, this is the track that you're going to take. You're going to start in molarity. You were given molarity of HCl or molarity of substance A. You need to change to moles of A. Well, on our roadmap, how we change from molarity to moles is by multiplying by liters. Well, this is not in liters. This is in milliliters, so we'd have to change that. Then to change from moles of A to moles of B, I'm going to use my mole ratio, which will be B over A. Then, to change to grams of zinc, which is what the substance asked me for, this will now be moles of zinc, and I can multiply by the molar mass to get to grams. So, let's walk through that math. Okay, so I'm starting with my moles or my molarity of HCl. Now, you might be like, why did you write it like that? Why did you write 1 mole of HCl for every 1 liter? It's because that's what molarity means. 4.0 molar HCl means I have 4 moles of HCl for every 1 liter of solution. I'm writing it like this so I can show you how the units cancel out. So what I'm going to do is I'm going to multiply again by liters. So notice how when I take my 4 moles of HCl for every 1 liter times 0.025 liters, which is the volume that it gave me in the problem. Again, I was given milliliters, but I had to change that to liters by dividing by 1,000. So notice how I have liters on the bottom here and then liters on the top here. Those liters are going to cancel, and the only thing that will be left is my unit of moles. So this is how many moles of HCl I have. Okay? Now I'm going to continue my problem down here just because I wouldn't have enough room to do my dimensional analysis. So now I have 0.1 moles of HCl. So I have done this step right here. I've changed from molarity to moles. Now to change from moles of A to moles of B, I'm going to use my B over A. Well, my B over A is, I know that I have 1 mole of zinc, because its coefficient is 1, for every 2 moles of HCl, so it's 1 over 2. Then to change from moles of B to grams of zinc, I am now going to multiply by the molar mass of zinc, and I know that there, I look on the periodic table, find zinc, there is 65.39 grams of zinc for every 1 mole of zinc. So notice how I have moles of HCl here and moles of HCl here on the bottom. Those units will cancel out. I have moles of zinc here and moles of zinc here. Those will cancel out. So my grams of zinc that I will have will be 3.27 grams. So I just multiplied through and got my value for my grams of zinc. Okay? Let's go ahead and let's try one more problem. All right, so here's the problem we're going to try. It says if 36 milliliters of H3PO4 react exactly with 80 milliliters of 0.5 molar NaOH, what is the molarity of the phosphoric acid, which is H3PO4? So again, how we need to do this is we need to make sure our equation is balanced. Then we need to identify our given, our known, and our unknown substances. So let's see, we have 3 hydrogens here, and we only have 2 hydrogens over here. So our hydrogens aren't balanced. Again, because I see a PO4 here and a PO4 here, I'm going to treat those as a unit. I have 1 phosphate. PO4 is called phosphate, so I have 1 phosphate here and 1 phosphate here. And then I have 1 sodium here and 3 sodiums here. And then I have 1 oxygen here and 1 oxygen here. Oh, I forgot. This is 3 hydrogens, and then this is my 4th hydrogen. So I actually have 4 hydrogens on the left. So here's what we're going to do. I'm going to go ahead and balance my sodiums first. Because I have 3 sodiums here and only 1 here, I'm going to go ahead and put a 3 here. And I'm going to see how that changes my, my balancing. So now I have 3 hydrogens here plus these 3 hydrogens, which gives me 6. And on this side, I only have 2 hydrogens. So I'm going to go ahead and in order to get these 2 hydrogens up to the 6 that are on the left, I'm going to put a 3 right there. So now that equation is balanced and ready. So now my equation is balanced. Now I need to identify my A and my B. Well, again, in order to do that, I'm going to go ahead and go to our mole map here. What information was given to me? I know this looks really overwhelming, but what information, this is all the stuff we've done, what information is given to me? Well, I've been given volume of H3PO4. I'm given volume of NaOH and molarity of NaOH. So if I know the molarity of something and I know the volume of that solution, we just learned I can convert to moles. So basically, I know the molarity and I know the volume. So I'm going to take my molarity times liters, and that will get me to moles. Okay, so that means this substance, NaOH, is my substance A, and it asked me what is the molarity of the phosphoric acid, which means that is substance B. So now I'm going to go ahead and I'm going to convert. So I am starting in, again, molarity of A. Starting here, I'm going to convert to moles of A. Then I can convert to moles of B. Then I need to look, what did it ask me to find? Well, it asked me to find, whoops, what is the molarity of the phosphoric acid? Well, in order to find the molarity of the phosphoric acid, I need to find where that is. Oh, well, here is molarity of B. So in order to change from molarity and volume of my given substance, I need to multiply by liters to get to A, multiply by my mole ratio, and then divide by the liters of substance B. Okay? So, here we go. So I've got 0.5 molar NaOH. And again, how I can write that is by doing 0.5 moles for every 1 liter. Then I'm going to, what did it say on the other page? It says to multiply by liters, and I have 80 milliliters of NaOH. So just to simplify and make this go a little bit quicker, that is 0.08 liters. So now doing this conversion, I've converted to moles of substance A. Now to convert from moles of A to moles of B, I need to look at my mole ratio. Well, my mole ratio is B over A. So now I'm going to multiply by 1 over 3. So I have 1 mole of H3PO4 for every 3 moles of NaOH. This will get me to moles of B. Now that I am in moles of B, I need to find the molarity. In order to do that, I'm going to divide by the liters of that solution. I know that it was 36 milliliters. So now I'm going to multiply by 1 over, again, to divide by liters, I need to divide by this amount in liters, which is 0.036 liters. Now, you don't have to write all this out in dimensional analysis. What I could have done is I could have just said this equals, found my moles, and then divided by 0.036. I'm just doing it all written out in dimensional analysis. Again, there are multiple ways to do this. Find the way that works for you. As long as it gets you to the correct answer and you understand it, that's okay. So I'm going to take 0.5 times 0.08 times 1 divided by 3, and then divided by 0.036 liters, and that will give you my answer. So I'm going to go ahead and calculate that. And I get that my answer is 0.37. Well, what was this unit supposed to be in? Well, let's go through and cancel out our units. I have liters here and here. I have moles of NaOH here and moles of NaOH here. The only units that I have left is moles of H3PO4 divided by liters. Well, what's moles divided by liters? Remember, moles divided by liters is molarity. That is the unit of this substance. That's the molarity of this solution. So it asked me what's the molarity of the phosphoric acid. This would be the molarity of that phosphoric acid from our reaction. So here's what I want you guys to do now. You should have an example problem that I want you to go ahead and try. If you have any questions on it, make sure you let me know. I'm happy to help you guys through and using your mole map and stuff like that. That ends our video over solution stoichiometry. Thank you guys for watching.